Okay, then share. Morning, everybody. Okay, so we're going to finish up the GI tract today. This is my cool little slide that I made. Oops. So we'll have poll questions, so please open up poll everywhere. Then we'll have current events, completing the GI tract with discussion. On Wednesday, we begin proteins, photosynthesis, and fiber. So there are videos for you to watch for that. And Wednesday is the last day for you or a member of your group to come talk to me about your project. All right, how you're going to present so we can discuss ideas, expectations. I have office hours from 9 to 10. I had some folks come in this morning. I talked about it with Christy. And I will have office hours after class from 12:30 to 1:30, or if people are still there, I'll be there. But that's one of the deadlines. And then next week on the 30th, when your individual outlines and annotated bibliographies are due. I think somebody was saying that you're already a third of the way. Was that you, Christy, through the semester and hadn't had much work yet? Well, let the games begin. Okay. Are you ready? Three, two, one. Chylomicrons contain more triglyceride than any of the other lipoproteins. True or false? Chylomicrons. I have to stand up. Three, two, one. Right, the answer is true. Chylomicrons are a member of a class of lipoproteins. Lipoproteins are proteins that transport fat or lipids throughout the body after they get absorbed from the intestinal tract into the bloodstream. Your and they're all made up of the same four components. They're made up of protein, cholesterol, phospholipid, and triglyceride. But the composition of those different fats and protein change as they move throughout the body and on your diet and on your genetics. But the chylomicron is the first one that leaves your intestinal tract and most closely resembles what you just ate. So your chylomicron is the one that's highest in triglyceride if you had a meal that's high in fat or high in carbohydrate. And then as it travels through the bloodstream from the lymphatic system into the bloodstream, right throughout the circulatory system, the composition of those change. And we'll talk more about HDLs and LDLs when we look at heart disease. Get this one right. True or false? Chylomicrons are absorbed directly into the bloodstream. I think I better have some more coffee. 5, 4, 3, 2, 1. Okay. No, I thought I just said it. Maybe I didn't, or maybe somebody blinked, but I don't know if you can appreciate my artwork, but this is to show you what's going on in the intestinal tract. So what we have here, we have the triglyceride is broken down into glycerol, short chain and medium chain fatty acids, long chain fatty acids, and monoglycerides here on the left. These long chain fatty acids and monoglycerides have a lot of carbons, which makes them hydrophobic. So they're packaged differently. They're packaged into something called a micelle, which then moves into the intestinal cell, is packaged with proteins, cholesterol, and triglyceride, not triglycerol, and that forms the first lipoprotein of the digestive system, the chylomicron. And because it's hydrophobic, it first moves into the lymphatic system. Ultimately, it gets into the bloodstream, but first it moves into the lymph. If anybody has any questions, please ask them. This is kind of a summary slide that I had. So the short chain, medium chain, and long chain fatty acids, short chain, medium chain fatty acids and glycerol move directly into the bloodstream because they are hydrophilic. They don't have as many carbons as the long chain fatty acids and the monoglyceride. So because they have less carbons, they're more water friendly. So they just move right through the intestinal cell into the bloodstream. This was the first slide, I think, in that series of slides that I went over in the video on fat digestion and absorption before I tried my hand at art and fat digestion. This slide shows you the intestinal tract, right? The contents, the chyme has crossed over the pyloric sphincter and entered the small intestine. And it's here where the lipases on the intestinal cell wall and the pancreas start breaking down the fat after bile has emulsified it, broken it down into smaller globules so that the enzymes can then act on them. And the breakdown products of triglyceride, as listed on the previous slide and on here, glycerol, I guess you can't see it at the top here, short and medium chain fatty acids, long chain fatty acids, and monoglycerides. The hydrophilic molecules, as I just said in the previous slide, move across the intestinal cell and into the bloodstream, or capillaries. Capillaries are the tiniest diameter blood vessel. All right, so that's the bloodstream. But here on the right, it shows how the long chain fatty acids and monoglycerides form that micelle, how the micelle then moves into the intestinal cell and forms the chylomicron. If we look at the right side or the right villi on this slide, it moves in, the chylomicrons move into the lymphatic system and ultimately into the bloodstream. Questions about fat digestion and absorption? Oh, okay. Let me make a note to myself. I want to ask you a question with a show of hands. Wait a minute. Which feels? I'll be right with you. Don't go away. Oh, well, I might as well do this. Sorry. Which of the following is not available for energy during a long-term fast? Liver glycogen, body fat, or body protein, which is not available for energy during a long-term fast? Five, 4, 3, 2, well, now you get longer because my mouse disappeared, so. Here we go. 1. I talked about the economics of feasting and fasting, and shows you a picture of my son, Jeffrey, and these amazing donuts, but that's beside the fact. We talked about short-term and long-term fast. Why is glycogen not available during a long-term fast? Can anybody tell me? You can just call out.
It can only be stored in the liver for about a day and a half, I think, in the liver.
We have a limited capacity to store glycogen. So we define a short-term fast as that time in which the body uses up glycogen. And depending on how much fat you have in your body, it can be used for short-term and long-term fasts. But when we talk about a long-term fast, so that's that nebulous period, I think I said between 3 and 7 or 10 days, the body is transitioning into a long-term fasting state. In that long-term fast, glycogen stores are depleted. The body is continuing to draw on fat for energy, but it also begins to break down body protein. And now we're talking about muscle. In the next unit, when I talk about proteins, I'll talk about the different functions of protein. Understand that when the body begins to draw on body protein for energy, it is sacrificing all the other functions because energy is lowest on the list of priorities for the body to use, all right? We don't want to be using our body protein for energy. And when the body is using protein for energy, all right, so it breaks down those amino acids, right? So protein is made up of long chains of amino acids. It gets broken down into individual amino acids. The body doesn't use nitrogen for energy, so that nitrogen goes to the kidneys and gets excreted. So here's a case where there is a toxin being formed in the body because first that nitrogen forms ammonia. But it pretty much, as long as you have a functioning liver and a functioning kidney, in the liver, that nitrogen forms urea, which then gets excreted from the kidneys. So that's the only toxin I can think of that the body has. That's another time. So we have amino acids that are then, the carbons from the amino acid are going to be used to make glucose. Now at the bottom part, we have fat that gets broken down for energy. Triglycerides are broken down into that 3-carbon glycerol backbone and fatty acids. So it's not on this portion of the slide, but the 3-carbon glycerol can form glucose. We're actually going to talk about this when we get to fitness and fuels that are used for muscle. But the fatty acids are then broken down into 2-carbon fragments, and they form what are called ketones, which a lot of you may have heard of with respect to the low-carb diet, that you're supposed to go into ketosis. Ketones get excreted in the urine, but these 2-carbon fragments can also be used for energy. It's not the preferred source, but in the absence of adequate glucose, the body will use ketones for energy. Questions about that? Okay. Oh, and just to be complete, when we overeat, this slide was to show you that it doesn't matter where the calories are coming from, whether it's carbohydrate, protein, or fat. When you consume excess of what your body needs with respect to to carbohydrate, they're broken down into glucose. And once the glycogen stores are filled, they form triglyceride. Fat gets broken down into fatty acids and glycerol. And then if it meets the body's needs for those, the excess gets stored, resynthesized into triglyceride. Protein, once it has been used by the body for whatever functions the body needs it for, if we consume excess of what the body is using, nitrogen gets excreted and the carbons will form fat. So any macronutrient consumed in excess of what the body needs can form fat. We have a limited capacity to store glycogen in our liver and muscle, but we have an unlimited capacity to store fat in our in our adipose cells. That's my summary. Chemical digestion, wait a second, is a series of catabolic reactions, true or false? Oh. Are you guys getting this slide?
We can see the question being displayed, if that's what you're talking about.
But it's not yeah, you're not getting to answer it? I don't see any results.
Yes, we can.
Somehow, let me see. All right, Leanne, let's play. All right, everybody gets it right. The answer is true. Chemical digestion is a series of catabolic reactions. Catabolic means taking big molecules, enzymes, energy, and water, and breaking them down into smaller molecules. Anabolic is taking smaller molecules, putting them together using enzymes, energy, and water, and making larger molecules. Catabolic reactions are hydrolysis reactions, hydro meaning water, lysis meaning splitting apart. Anabolic reactions are also referred to as condensation reactions because water breaks off. These molecules come together, and we've talked about condensation reactions, or I have, when we have monosaccharides coming together to form disaccharides, when we have amino acids coming together to form protein chains. Those are all anabolic reactions. Choking occurs when the bolus gets caught in the esophagus. True or false? Choking occurs. Five, 4, 3, 2, 1. Choking occurs when the bolus gets caught in the trachea. Okay. When the bolus is going down the esophagus, that's called swallowing. But when it gets caught in the trachea, that means it's going down into your lungs, and that's choking. Oh, okay. Wait, I don't want to do this one first. Where am I? All right, I'm going to stop here and pause and look for my current event slide because I have it here somewhere. Oh, I put it at the very end. Good girl, Leanne. Okay. Actually, I want to not share this anyway. All right, so I want to, any questions about the poll questions? Any questions about the questions? All right, so we'll have current events, Jackie, Scarlett, Annabelle, and Jordan. But first, I wanted to ask you a question. I'm trying to figure out how to do this, though. Let's see. I want you to answer this in the raising your hands. Okay, let's see. How do I do this? Participants. Oh, I show that. Okay, so I was talking about how fat is more complicated when it comes to digestion. So I want to ask you, just without thinking about it, I want you to think, well, okay, two meals, toast and eggs or cereal and juice. Which one makes you feel fuller? And if you think it's cereal and juice, raise your hand. Which one makes you feel fuller? Cereal and juice or toast and eggs. Raise your hand if you think it's cereal and juice, or raise your hand in the participant thing. Okay, so why would you say, what's my question? Why is your gut reaction to say eggs and toast makes you feel fuller? Julia. Oh, well, why did you, just for what it's worth, nobody said that they thought that cereal and juice made them feel fuller. Gabby, why did you say eggs and toast?
Personally, from experience, whenever I have cereal for breakfast, I just get hungry like 1 hour later. And when I have eggs, I stay full for like a few hours.
Okay.
Personal experience.
Rita.
I just feel that solid foods make me feel a lot fuller than liquids. So probably that.
Okay. Alejandra?
Because the eggs have protein and fat, and that takes more time to digest.
Is that why you said that, or is that what you're now using, the vast amounts of knowledge that you've accumulated as a result of this class?
That's why I know that.
Oh.
That's why I always eat eggs in the morning.
Oh, okay. For some people, they feel, I don't know if you know why, but my hypothesis, and I haven't studied this, is because I don't know about protein taking longer, but fat, and we've looked at fat. We've just looked at all 3 macronutrients and their digestion and absorption. Fat takes longer, all right? How much longer? I haven't looked, but the long chain fatty acids and the monoglycerides have to be packaged. And also, fat is the last thing that leaves your stomach, all right? When you consume food, Sasha, what did you have for breakfast? Have you had breakfast?
I've had this delicious coffee so far.
Okay, that doesn't help me. Let's pretend you had, what would you, if you could have something with your delicious coffee, what would it be?
I would have a protein bar, maybe.
Okay, so we have coffee and a protein bar. Work with me, folks. You chew it. Salivary amylase begins the digestion of what? Just call it out.
Bolus.
Well, that's what's being formed, but salivary amylase begins the chemical digestion of what in the mouth?
Carbohydrates.
Carbohydrate. Okay, so now we have the formation of a bolus, which crosses over the epiglottis, goes down the esophagus, crosses over the cardiac sphincter, and enters what? What organ?
The stomach.
The stomach. In the stomach, carbohydrate, what happens to carbohydrate digestion in the stomach?
It pauses.
It pauses. Why does it pause? Digestion of what begins in the stomach?
Proteins.
Protein. Salivary amylase is a protein. Enzymes are proteins. So the amylase itself is getting digested. So carbohydrate digestion pauses in the stomach. Protein digestion begins, and that coffee and protein bar that was a bolus now combines with other gastric juices and forms a semi-liquid mass of partially digested food, just kind of rolls off your tongue, called chyme. This chyme then crosses over the pyloric sphincter and enters the small intestine. Now, as it's moving across the pyloric sphincter, the fatty portions of the chyme are separating out because fat and non-fat don't mix. Fat and water don't mix. So the fat is the last thing that leaves the stomach, which is another reason why people might feel fuller longer when there is fat in your meal. I've always recommended as a dietitian to have fat with all your meals, because if you're one of these people for whom it makes you feel fuller longer, then that's a good idea. Some people feel protein makes them feel fuller longer. Some people find that if they drink water or something before a meal, individual results may vary. But physiologically, fat is the last thing that leaves your digestive tract and may be why you feel fuller when you eat fat. Now, let me just continue that digestive exercise here. As it crosses over the pyloric sphincter and enters the small intestine, the accessory organs get involved. What are the 3 accessory organs? Yes, Alejandra.
Liver with gallbladder.
Phone a
Kidneys?
friend. What?
No, kidneys, no. Liver,
No.
liver and gallbladder. And I forgot.
Can anybody else know what the 3rd accessory organ is?
Pancreas?
The pancreas. So as these contents move across the pyloric sphincter into the small intestine, the accessory organs get involved. Now, what is the pH of the contents leaving the stomach? Okay, so yes, no, low. Low pH means acidic, high pH means alkaline. Why would the contents of the stomach be very acidic?
Because of the bile that's used in digestion.
No, but that comes up. What
Is
other?
it the hydrochloric acid?
The hydrochloric acid in the stomach lowers the pH of the contents. So what has to happen as the contents move into the small intestine so that that low pH doesn't destroy everything? I know. You didn't know how much you were learning. We have a secretion from the pancreas called bicarbonate that neutralizes the chyme. The bile that's produced in the liver and stored in the gallbladder emulsifies the fat into smaller globules so that enzymes from both the pancreas and the villi of the small intestine then break everything down into the component parts that ultimately get absorbed as chylomicrons, as amino acids, glucose, short chain, medium chain fatty acids, and glycerol. And what's left over moves across the ileocecal valve into the large intestine and ultimately gets excreted. Welcome to the digestive tract. Any questions? That's my favorite. I'm just saying, I really like it. I want you should. Okay. Jackie, what's your current event?
All right, let me pull this up. Okay, so I was looking through different diets and I came across one that I've never heard of before. It's called the Blue Zone diet. So blue zones are regions of the world where this diet's creator named Dan, I don't know how to say his last name, claims that people live longer than average. And these areas include Okinawa, Japan, Sardinia, Italy, this town in Costa Rica, Greece, and somewhere in California. So basically the characteristics that he contributes to their longevity is some of them are food related, some of them are nutrition related, some are not. But the first one's family. The second one's semi-vegetarianism. So the majority of food consumed is derived from plants, constant moderate physical activity, social engagement, and legumes. And there's a lot on it, but basically like the lessons that from blue zone people are moderate to regular physical activity, stress reduction, moderate caloric intake, a plant-based diet, moderate alcohol intake, and he notes especially wine, and just like engagement in social, family, and spiritual life. And then a study on this found that there may be some fraud and error in the statistics used to designate blue zones, but that there's a lot of substantial health benefits of the diet and lifestyle modifications that were in these areas. So just kind of I thought it sounded like the Mediterranean diet when I read this, but it's just kind of another name for it, in my opinion.
Well, in another publication.
Yeah.
But yeah, well, what's not to like? I think that those are good recommendations. I don't know, are there blue zones in the United States? Are there blue zones in other countries? I mean, I agree. All those things are great if you have the resources.
Yeah.
I think we always have to remember, if you have the resources, if you have the support, if you are able to get those foods, and in those places it may be access may be easier. I'm not sure, what they're doing to reduce their stress. I think that's a huge thing. I think that we undervalue stress reduction in terms of quality of life. So yeah, sure. Why not? Okay, Scarlett.
So for mine, I found this New York Times article and it kind of caught my attention. The title is Are Mushrooms the Future of Wellness? And it more caught my attention because that's like my least favorite food ever. But anyway, the article doesn't have a lot of scientific support, but it was still interesting to read. So the whole idea of the article was that the research is starting to show that mushrooms have the ability to soak up and escort waste from our cells, and that they actually have a digestive system almost identical to that of humans. That was a quote from Liz Smithers, who studied herbal sciences and medicine. Again, they didn't have like a study to back that up, but I thought that was an interesting quote. And then the benefits they listed were immune defense and support. They're super high in antioxidant content, and so that would promote immune support benefits. And then the second one was mental focus and energy. And there was one study done in 2016 on rats that showed a specific mushroom was promoted peripheral nerve regeneration. But again, nothing has been done on humans to support that. And then the last one was skin and gut health. I just thought the article was interesting because it showed all these products that are like hitting the market, like certain powders, tea, coffee, even like a spray that all have some form of mushroom in them. And it's just something I haven't seen ever, but it seems to be super popular right now.
So what do you think about that? Before you force yourself to spray mushroom in your mouth.
I'll never do it, but they did bring some interesting points up, I guess.
Could you send the link to me? I'm just curious because, first of all, it's an advertise. It sounds like they're promoting the product. There are lots of different types of mushrooms. It depends on where they're grown as to what the characteristics, what the mushroom has in it. That fact that they have their own digestive system really scares me. But they do have a relationship with some mushrooms have relationships with the plants around them. They have a symbiotic relationship, but I'm not sure what that other stuff means. And in terms of, all the properties, how were they measuring these immunes? They certainly, if they're doing it on people, then I would give it a little bit of credence, but I'm guessing that you can test rats. I know you can test rats much more and control the environment in animal studies and in labs. So I'm just guessing that that's where that's coming from. Eat mushrooms because you like them. I don't know how many you'd have to eat in order to have these magical properties or medicinal properties. A lot of our medications come from plants. I'm not playing that down, but before we start using food as medicine, let's make sure that we know what we're getting. Thank you. Annabelle.
So I found an article that focuses on the potential new heartburn drug studies at the Vanderbilt University Medical Center. So this is an investigation drug that binds bile acids in the stomach, which can reduce the severity of heartburn symptoms in patients with GERD, which is Gastroesophageal Reflux disease. And bile acid reflux occurs when, as we already spoke in class, when the bile, which is a digestive liquid produced in your liver, backs up into your stomach as well as the esophagus. So this new investigational drug binds bile acids in the stomach with a technology that controls the release of drugs in the gastrointestinal tract. And this can help avoid the injury of the lining of the esophagus as well as stomach and colon. And the results of this trial were positive, and they led to the reduction of heartburn symptoms.
Cool.
This was released in 2020, and the study was conducted from March 2016 to April 2017.
And where was it published?
It was published, I looked in the Vanderbilt University Medical Center website.
Okay. So what would you want to know about this before you, say, would start taking this medication?
Well, the sample size was 280
Okay.
adult patients, so that's really, that's not a large amount of
Yeah.
patients. So I don't know if I would trust this.
Well, was it placebo controlled? I'm guessing it was placebo controlled. So it's kind of ticking some of those boxes. Has it been FDA approved?
They divided the 280 patients into 4 groups, and one of these groups was had the placebo.
Okay. Has it been approved by the FDA? Okay. And what's it called? Wait a minute. I want to write this down. No.
It's called the IW 3718.
Oh, that sells me on it right away. They better find a catchier name than that. Okay, Jordan.
Yeah, so my current event was a pill. You guys have probably seen the commercials for it, but it's called IV Guard. Last week we talked a little bit about IBS, and I've seen this commercial a lot of times. And I've actually tried it before because I have it, but I wanted to learn more about it, and so I wanted to see if it actually, because it honestly didn't help me, and so I wanted to see if it's actually like a scientifically proven drug. And so after looking into it a little bit more, I found out that the main ingredient in it is peppermint oil, and the website says that it's supposed to work to regulate digestion and absorption by managing symptoms and triggers associated with IBS, and it says by normalizing the lining of gut and balance bacteria in the small intestine. And so the reason why I think that it's this whole like scientific blurb at the top doesn't really make sense just to be kind of fixed by taking peppermint oil. I know that a lot of people have tried peppermint tea to kind of ease like stomach pains, and that's just kind of like a medicinal herb that people might use. But to pay, I think it said it was like $30 for a box of pills. So it seems kind of a lot just for like a peppermint extract. You can probably buy it at Whole Foods or something for a lot less. And it wasn't really proven to help. I know the ratings weren't very high, and I think a lot of it has to do with the placebo effect of taking this pill. A lot of IBS triggers are from feeling like anxious or stress, and I think if someone takes this pill and I think it's going to help, it might ease their stress symptoms a little bit, and it might actually help them long term, but it's not actually the pill that's helping it, it's the lowering of the stress. And so I think that overall I wouldn't really recommend this medication to anyone, just because, I mean, I tried it for a very short amount of time and I obviously don't take it anymore, but kind of looking into it more, I maybe wish I had looked into it before, just because it would have saved me time and probably money, because it's not really a cheap pill to take, and it says you even have to take 1 to 2 capsules 3 times daily. So you're basically taking like 6 pills, kind of like Professor Simmons' trial when you had to take, I don't know how many pills it was a day, but just a ridiculous amount. It's not like you're gonna go out to a restaurant and put 3 pills in your hand and take it. It's just not realistic. So that was my event.
So let me, first of all, well, let's clarify, you're an anecdote. So you're an N of 1. So that's your experience. I just, but it's valid for you. My question is this a medication or a supplement?
I'd say it's a supplement.
So supplements aren't regulated. So, and they don't have to be studied the same way medication is. So did you find are there any double-blind placebo-controlled studies with this?
No, I really couldn't find any like official studies that were done. Their website had kind of like more testimonial type things, but it wasn't a scientific study.
So before you spend money on products like this, because depending on who you are and what your situation is, you may feel very vulnerable, and it worked for somebody else. That's a great PR. Testimonials are very compelling, but they're not science. So don't buy it for science reasons. If you understand that and you still decide, just know that there are risks associated. Okay, all right, thank you. Let me see what else I have let me share my screen again. Hello, oh. I don't recall if I answered these already. Sorry, folks. These were on one of the Padlets. Somebody asked, are complex carbohydrates any better? And I guess my question has to be, any better than what? If you recall who you were, that's why one of the reasons why I asked you to post your name. I don't know what they're any better than. So they're good if you like them. They are long chain carbohydrates that, you know, their sources are good. It depends on what you choose. Jordan, do pre-workout supplements, did I answer these already in class? I don't think yeah. Do pre-workout supplements or powders actually have an impact on your workout or muscle recovery? Self-disclosure, I'm not a sports dietitian. I don't know. Nancy Clark, James Fell would be people that I would encourage you to look to for that. I will tell you that I'm 99% sure they would be opposed to supplements and powders until you eat food, but show me I'm wrong. Does your body get dehydrated when you eat, when you wake up in the morning? Maybe. Should you drink an entire glass of water before eating anything? Only if you're thirsty, only if you want to. There's no reason, science-based reason, to drink water before a meal. Scarlett, what do you think about apple cider vinegar?
I said this the other class. I don't really like
so.
the taste, but I have tried it a couple times just because I've seen it from a lot of like fitness blog type people. But yeah, I don't like the taste, so I don't.
Then don't drink it. I don't think that there's any magical properties to it. It's, you know, I would say it's really acidic and it can bother you, but the pH of your stomach is really, really acidic. So that's not what's bothering you. Which is better for healthy living? Whatever works for you. And Pepe, what and when to eat around workouts? Offhand, I would say, first of all, don't eat anything right before a workout. You need to have time for things to digest. So you don't want to be working out on a full stomach or before a performance. Carbohydrates are the most easily absorbed, digested and absorbed, simple carbohydrates, and they provide energy for your muscle. Does that answer your question?
Yes, it does. Thank you.
The importance of when we eat. Is breakfast really the most important meal of the day? I feel like I've answered this, but because I have two classes and you're all on a screen, that's my excuse and I'm sticking with it. Is it the most important meal of the day? Not anymore. We've been let off the hook for breakfast. Eat it because you like it. Okay. I have posted another Padlet, which I'm kind of reminding you that your engagement also includes participating in some of these tools. And this one, if you want to click on where you'd like to be or where you've been, I'm going to start looking at this for questions next class, because I think I've covered all the other Padlets. If you have any problems accessing it, it's in assignments and there's Padlets there. I know what you see is different from me. So if you have any specific questions, let me know. I'll hop on Zoom and we'll find it. And then number of you expressed an interest in the green nutrition topic, and a number of you wanted to follow up on those questions. So I also opened up another Flipgrid. So if you go to the Flipgrid that I asked you to do before classes started, you'll see that there is a new one called Green Nutrition. If you want to start a conversation there, I'll be looking at those. Feel free to record a comment or comment on a recording and keep the conversation going, because it was obvious to me that a number of you are interested in the topic. Okay, so what I'm going to do now is put you in breakout rooms. I sent you or posted under announcements are the discussion questions. So how many people do I have? 27 people. How many questions do I have? 5 questions. So I'm going to divide you into 5 groups, and please somebody, be the group leader, kind of coordinate what you're looking at. Somebody write down the answers. You can put them on the document, hopefully. I made it so that you can edit it. If not, let me know and I'll change it or pull my hair out or both. And then we'll get back to class. What time is it? In about 10 or 15 minutes or whenever you're done, and talk about the answers, okay? Any questions? All right, let's see. 5 breakout rooms. On your mark. Get set. Go. Oh, Marcy, you didn't want to go?
I have to all the others.
Oh, that's funny. Oh, you're here. I didn't know if you'd gone and it was just your picture.
No. But I have a couple things I have to do, so I just, you know, and sometimes I will explain to them that I'm auditing.
That's
sometimes
great.
I say nothing, but in this case, I figured why confuse the issue.
Sure. No. Well, some of these are a little more content dense questions, so it'll be interesting to see what they come up with.
Yeah. No, it's good. It's good.
All right. Well, I'm going to go finish my Luna bar and go to the bathroom.
Absolutely.
Oh, I'm going to turn off the recording. And group 1, what's the difference between short-term and long-term fast in terms of what the question says?
So for short-term fasting, the body uses glycogen from the liver and muscle for energy, and then it will go to the triglycerides and the body fat. And then for long-term, the body starts using protein for energy, amino acids to provide ketones, and body fat. And it uses protein when it has to sacrifice all other body functions, so no glycogen or body fat.
Okay, so body fat is going to be used for both, depending on how much body fat the person has. And they're being used at the same time. All right, so it's not like the body preferentially uses glycogen and then body fat. It's using what it can if there's a starvation. So like with Yom Kippur, I'm not going to be losing that much, probably because I won't make it past breakfast. But it's a short-term fast. I have plenty of stores. But they would both be used at the same time. And then, but the glycogen on me at least would run out first. And then in a long-term fast, whatever fat stores are still there and muscle begins to get broken down, or body protein. Okay, I think sometimes the way I teach it, people think that there's a distinct order, and a lot of these things are happening simultaneously. Okay, all right. Group 2, talk to us about MCT oils.
Yeah, so MCT stands for medium chain triglycerides. And this hypothesis that they help with weight loss and appetite control is because they're hydrophilic, which essentially means they're absorbed more quickly, digested faster, etc. Another thing we found when we did some extra research was that they claim to increase the release of these hormones leptin and peptide Y, which are hormones that are responsible for making you feel more full after a meal, which could also be a reason why they're used for weight loss and appetite control as well.
Okay. So because they are hydrophilic, they're absorbed faster, as opposed to, as we were saying, the long chain fatty acids and monoglycerides have to be repackaged. The time differential, not sure. It's just that there are more steps involved. Okay. Group 3. Talk to us about stomach muscles surviving denaturation and the acid environment.
So basically, what we found is that the stomach doesn't digest itself because it's lined with these cells, the epithelial cells, and those cells produce mucus, which then forms a barrier between the lining of the stomach and the acid contents. And the enzymes, which make up part of the digestive juices that we talked about, are also secreted by the stomach walls from the glands with no mucus barrier.
So wait, so tell me, the other group, how are these enzymes involved in protecting the stomach from digesting itself? Or are they just there? You just put them in because it was in the paragraph.
Maybe.
No, as far as I know, the enzymes aren't involved. Enzymes chemically digest food. I don't know how they're protecting the stomach from digesting itself, which would be a chemical reaction.
Okay, so it's just the barrier of the mucus.
My understanding is that's it. So take the other stuff out.
Okay.
Please.
And then for the reflex, well, this was kind of like said in the video that we had watched, but the sphincter weakens, and then the stomach contents then flow back into the esophagus, and the reflux of the stomach contents into the esophagus is called the how do you pronounce it?
I don't know. Gastroesophageal reflux?
Yes, reflux disease,
I don't-
and the frequent acid reflux is another cause of GERD.
So why are you feeling reflux? Why are you feeling it burning? Why is it uncomfortable in your esophagus? I think I made group 4 answer this as well, but what's going on in the esophagus? Yeah, Kat.
Do you want me to answer?
Sure.
Okay, so essentially the esophagus can't create this mucus to protect from the acid, and the esophagus and the small intestine can't protect like the stomach can, because the stomach has these acids to protect against it.
Right. So you have this burning in your esophagus because you don't have mucus protecting the esophagus. So that's why you feel the burning. And the concern is over time with severe reflux is that you can wear away at the esophageal lining. And for example, someone who suffers from bulimia with the constant refluxing or throwing up with acid moving past these cells, that you can cause something called esophageal rupture, in which your esophagus ruptures it, and that can be a long-term consequence of that exposure to acid and wearing away. Yeah. All right, group 4, talk to us about ulcers.
So an ulcer is an infection with the bacterium H. pylori, and kind of as we spoke about before, the question was, why would someone develop an ulcer in their duodenum? How do you say that, Professor?
I say duodenum or duodenum. I think they say duodenum in British. I think that's how they said it.
Right. Duodenum. So when this happens in your esophagus and small intestine, these parts of the body can't create this mucus. So if it were to occur in your stomach, it'd be okay because of the acid in your stomach. But due to this, the ulcer creates an infection. And medications like ibuprofen and aspirin particularly can cause this as well.
Right, so there is a category of medicines called non-steroidal anti-inflammatories, aspirin, Advil, not Tylenol though, and what these NSAIDs do is they can irritate the stomach lining and cause ulcers because of that effect. What they do is they produce a chemical that suppresses, I think, mucus production. So I think, don't listen to that part of the recording, but there's a chemical interaction that can lead to increased exposure, which is why it's recommended to eat something if you're taking NSAIDs so that you're not consuming them on a full stomach. Okay. And there are certain illnesses that can increase acid production, and that can also cause an ulcer. But yeah, the fact that one of these two guys who discovered H. pylori wound up infecting himself just to prove a point, not that loyal to my causes, but I got a Nobel Prize for it, so. And group 5, is it possible to eat too much protein? What happens to the body?
So it is possible, but the excess protein is stored as fat, and there's actually like an unlimited capacity to store fat. So the surplus from the protein, so it becomes amino acids and it's exerted, and the nitrogen is excreted as urine.
Okay, right. So it's called deaminate, get rid of the nitrogen, the amino portion, because we don't get energy, and we don't use the nitrogen. It's used to make other nitrogen containing compounds or other amino acids, the non-essential amino acids. And then those carbons can be stored as triglyceride. Any questions about the questions? This is good, very good. Any questions about what we covered? All right, there's one more.
Yes, I have a question.
Please.
What are ketones?
Ketones are actually acids, keto acids. They are made from these 2 carbon fragments that can come from amino acids called ketogenic, genesis of ketones, We have ketogenic amino acids, but we also can, the 2 carbon fragments that the fatty acids break down into can also form ketones. And so what happens is that they build up in the blood, and then when they're high enough in the blood that the body can't process them, the phrase we use, at least with diabetics, is they spill over into the urine and you excrete them, which is why folks on these keto diets have these strips that they use to see if they're spilling ketones in their urine. It's not the preferred energy source for the brain and central nervous system, but in the absence of glucose, the body will use it. Is that your question?
Right. So the body uses amino acids to create ketones.
So we have, yes.
Rather than an energy source.
Yeah, so let me just show you a second. Let me just find it here in the slides. That's a good question. So let me share. Whoops. Come on, get big. Okay, if we're looking at this bottom part of the screen, we have protein and body fat that are being broken down during a long-term fast. So the protein is broken down into amino acids. We have what are called glucogenic, genesis of glucose, amino acids, and we have ketogenic, genesis of ketone amino acids. So the glucogenic amino acids will form glucose to be used for energy. The ketogenic amino acids will be used to form ketones. What this slide doesn't show is that you get ketones from both amino acids and protein. No, amino acids and fatty acids. Does that answer your question?
Yep, thank you.
Okay. Other questions?
I have a quick question.
Sure.
So we discussed that with the MCT oils, they're hydrophilic, so they digest quicker. How would that help with fat, like weight loss though? Because I would think like if it's digested sooner, you just get hungrier sooner. Like how does that work?
So the hypothesis, one of the hypotheses that I think Jackie brought up is that it may increase leptin and leptin production. And leptin, we'll talk about when we talk about weight control, is a hormone that lowers appetite and increases metabolism. How much? Not so much, but that's the hypothesis. That's why some people feel fuller after a meal because their leptin levels increase. And the hypothesis is that people don't produce as much or they don't pay attention to these signs, and that's why they keep eating. Does that answer your question? Other questions? These are good. Okay, so let's see, last thing. Okay, so I just want to remind you, assignments on the syllabus are closer than they appear. On Wednesday, we'll be beginning protein and photosynthesis. It's the last day to talk about your project, how you want to present, so I can tell you what I'm looking for. I'm not looking for a PowerPoint presentation. I'm looking for creativity. What's an annotated bibliography? If you didn't read the document, talk to me about it. Let me tell you what I'm looking for. And then next week, your individual outlines and annotated bibliographies are due. All right? I will be around from 12:30 to 1:30. I've got to go take a walk. For anybody that wants to come see me then, if you haven't talked to your group, talk to them. These are interesting times to do group presentations. I'd be curious to see what you come up with. And I'm happy to talk to you about ideas. And you go now. Bye-bye. See you next class.
Thank you.
Thank
You're
you.
very welcome.
Thank you.
Have a good one.